Hello, everyone. I hope you can hear me fine. I switched my mic again for this workshop, so if you can't hear me very well, just make sure you type it in the chat because I do not know. I tested it earlier, but it should be. Oh, okay. So, sorry about that. I had my YouTube still open and it was like crazy feedback, so I removed it for 1 second. Give me a second to go back to where we were. Okay. So, I'm just going to give everyone a couple more minutes to join and to come together today. We are doing this on a Friday. Usually it's a Thursday, guys. I know, sorry about that, but I actually had to fly back to Berlin yesterday, so it wasn't a real option for me, and there was so much class. You know, I just started studying at Polimi, so for those of you who know, it's a very different structure than I had before in Berlin. So I'm still figuring it out, but I'm really happy you guys are all joining me today here on a Friday. And it's not just me, we have an amazing guest. Her name is Rowan. I'm going to introduce her a little bit later. But I'm super excited, so thank you all for making it here. And as always, I'm going to introduce the guest and make a little introduction before we begin with the actual workshop. But I'm super excited, and I'm really happy that all of you guys are here. Also, if you're new here, drop it in the chat. I always like to see who's new and where all of these people come from. We also have a little split audience going on today because half of the people are on YouTube and half of the people are here. However, if you're here, the good thing is you can interact with us, you can talk to me, you can ask questions, and obviously get the most out of the talk we have today with our guests. But without further ado, I'm going to start my presentation because I don't want to waste any time we have with our amazing guest today. So I'm going to just go back to my presentation. 1 second, guys. Okay, so welcome to Workshop 8. This is still how to use AI in architecture, but we do have a special edition today, just like we did last time. And today's special edition is AI Augmented 3D Printing Edition. I did not know this was even a thing before I started following Rowan on LinkedIn, but now I know and I want to learn more, which is why we're here today. So, a little bit about our agenda. We're going to start again with a welcome and introduction. That's kind of what I just did. So I guess we already did that. I'm going to explain a little bit again what our workshop series is, what the point of this is. Then we'll talk about why AI in 3D printing, why we're even doing this, what's the point. We have a little guest introduction, and then, of course, the guest input and demo, which is the part we're all waiting for here. And at the end, as always, we have the Q&A and some resources I would like to share with you guys. But we are going to start with a little promotion because if you are watching this workshop right now and you say, oh, this is a really good workshop, I want to show my friends, you can, because this workshop is recorded for my YouTube channel. And if you scan this QR code, you can get to the YouTube channel. Please follow, like, subscribe. I don't know, I don't want to sound promo-y, but it really helps this channel grow and it helps me host better guests and just makes it really easy to give you guys better content. So if you like the workshops and you want to watch the previous workshops, they're all uploaded on my YouTube channel. I really appreciate all of you who are subscribing and who are making these workshops happen. But let's proceed. So a little bit about our guest. Maybe some of you already see her in the Zoom call, but today we're going to talk to Rowan Elselmy. So she's a computational architect and she's specializing in AI-driven design workflows and robotic 3D printing. I'm sure she's going to introduce herself much better than I'm doing right now, but I just want to give you guys a little intro of who we're dealing with today. She's an expert in AI integration across concept development, also Python scripting and Grasshopper refinement, which is super interesting for those of you who always ask me about Grasshopper and AI introduction into Grasshopper. I think this one's for you guys. And of course, she bridges creativity with fabrication-ready solutions. I think that's super interesting. And what are we talking about today? 3D printing. So how can we use AI to help us 3D print better in architecture and really go from the concept to the ready-made product? Why are we talking about AI and 3D printing though? What can this help us with? What is the reason for it? There's a couple of reasons why AI and 3D printing might be interesting to anyone or everyone, actually. If you're here, you're probably interested. But one of the reasons is it helps us merge creativity with fabrication. So a lot of people in architecture are stuck at the point of, I have so many ideas, but I don't know how to execute it. And where AI comes in, we have to remember we don't make AI think for us. We use AI as a tool to help us think. And in order to do that, I think AI is a great tool to bring you from an idea to an actual product. And I'm really excited to talk about that today. It also helps us create more sustainable and efficient construction solutions, which I think is incredible. As someone who studies sustainability at Politecnico di Milano, this is really important to me. So I'm incredibly interested in that also. And it helps us accelerate complex geometries. You all know, like when we model these crazy facades in Grasshopper, in Revit, some people do it in Revit, I do it in Grasshopper. It's really difficult to actually bring those to life and actually execute them. So I'm wondering how those two things can come together today. And of course, it helps us expand design freedom, which is always the main point that we want to talk about. But without further ado, I would like to hand over to our amazing guest. So, Rowan, please, I think the stage should be yours now to introduce yourself.
Hello, everyone. My name is Rowan Elselmy. I'm so excited to be here today. I think the AI Python scripting in Grasshopper is something that everyone should know about because it's very interesting. And then it's like a tool that helps you create even more. So today I'll be touching upon a few things to help you get started, but it's a matter of how creative you are and how you're going to use the tool. That's how it differentiates you. I used to be the head of AI integrations at Dion Dubai, and now I'm a lecturer at DMU Dubai. So I start next Monday, so I'm very excited for that.
Oh, congrats.
So I can share my screen and get started.
Of course, go ahead. You should be able to access it. Okay, here we go.
Okay, let's start. Okay, a little bit of background. I always wanted to learn Python scripting, but for me, if I'm not using it for a certain project, I don't tend to learn stuff. And then one time I had quite of a bit of a challenge at work, and I was like, why not try AI or ChatGPT to fix it using Python scripting? And it was so interesting, the fact that I learned Python scripting just by communicating with AI tools. So it was like a new level unlock of just using AI for learning, which is it became part of my master's studies that I'm going to show you now. So today we're going to talk about how AI augmented 3D concrete printing prototypes. So how it's a co-design like workflow between the designer itself and the AI. So it's more of a communication tool. So and it's co-designed between these two entities. So this was the initial output of my master's studies, which was from sound to 3D concrete printed facade. So basically, I went to a cultural heritage site and I started collecting the sound data from this place. And after collecting the sound data, I started extracting data from it, which is time, amplitude, and frequency, because these are the parameters used in something called semantic equation, which is the study of vibration and sound in water. So it's like, why not try to apply it in architecture? So the first part, I don't know if you can hear it, but the first part was extracting the sound data and just visually represent them. And then morphing all of these sound data together. And then this is basically the workflow. So as I mentioned, you have first thing, the capturing of the data, and then the extraction of the needed parameters, and then putting it into the equation or the main part of the whole thing, and then the output, which is 3D concrete printed facades. So when you start thinking of things and dissecting it in a very logical and simple manner, it helps you with prompting and it helps you with the final output. And all of this was done using ChatGPT and Python scripting within Grasshopper. And this is actually how it looks like. So you have the inputs, such as the sound file itself, and then the parameters. And all of these parameters were used later for optimization. So whatever the parameters I needed, I started adding it in the prompting. So I get the final output that I could test later for 3D concrete printing. This is another project that's inspired from still same it's still same workflow, but it was from sea, the sound of the sea, and it was actually the ripples of the sea. And now you can see it in this this is a shower wall near the beach, because where I come from there's amazing beach, so I was inspired from it. And
Mhm.
it showcases that you can start using this workflow not only for architectural like architectural realm. You can use it in different, maybe product design, maybe jewelry, whatever you want to do. And it was the same workflow. I just adjusted a couple of things and used it for another project. And this is like a 360 of the shower wall. And then because it was 3D concrete printed, we needed to test a couple of things. We needed to know if the pattern itself is it going to be printable or it will cause buckling. So we did like a prototype of a scale 1:1 of half of the facade, half of the shower wall, which had the most intense pattern. And as you can see, because of it going in and out, it created interesting shadows. And if you put it on the beach, when the sun is moving, it creates like a sort of a dynamic um, shower wall, which was pretty interesting. And also, the same workflow was used for a whole product line, which is landscape furniture near the beach. So we did like planters, we did benches and stuff like that. And this is like the bench with everything, like a certain scenario put to it, which was pretty interesting. And it all started with the idea of why not try it. So I think everyone should be really curious of how to start using these tools. So this was the get to know me part. Now we're gonna go right into the workshop itself. So the most important part is how you communicate with AI. And it's not really difficult, it's just it needs to be structured. So before even getting into the prompting, you want to do Python scripting. So you need to understand the process of Python scripting in general, which is more or less relevant to how you do Grasshopper scripting. So you have an input or set of inputs, you have a process, and then you have outputs. So the inputs, they can be parameters, they can be a text brief, they could be external data. And then the process itself could be something mathematical like the semantic equation. It could be something inspired from nature, maybe cellular automata or fractals or whatever your project or your research is based upon. Or maybe the process could actually be like constraints that you want to work around. And then the output could be something geometrical, maybe a mesh or a sub-D or something more analytical that you're studying something and you want like an initial kind of summary of it, maybe a mix between both. It doesn't have to be one input or one output. It could be a set of multiple things based on your own preference or what you're working on. So, for example, to go deep into it, it could be like a project context if you're doing something urban. So maybe the land use, the type of buildings, whatsoever. Maybe the constraints could be like site dimensions, orientations of the building, and stuff like that. And you can you can start dissecting it based on your own project. So for the okay, we can go right into playing with AI. So this kind of structure is how you convert it into your prompt. So you start your prompt with what do you want to do? For me, I'm using Rhino 7, so it's a different Python language. It has like an old Python component. So if you're using Rhino 8, just state that you're using Rhino 8. If you're using Rhino 7, you state that. And then you say, what do you want to design? So for example, for this workshop, we're going to design like a 3D concrete printed column. And I wanted something that is like a central circle and has multiple circles around it, and then maybe twist it and see what it would look like. And basically, it's better to start simple and then try to make it more complex. When you start to bombarding AI and just wanting to create something really complex from the get-go, it kind of you lose the communication workflow between you and the AI. So it's better to just start simple and then start building it up. So the first statement is, what do you want to do? And then the second one, what are your inputs? So for example, in this input, I wanted the radius of the circle, and then how many like attachments are to it, and then the distance between each attachment and the other. And in this one, I added maybe an additional parameter could be a rotation. And then the process, the third sentence was like the process, that it's just a series of shapes and then that are stacked on top of each others. And if you're using Grasshopper, there's kind of keywords that you already know about, so it's better to try to incorporate them. So if you know how to do it on Grasshopper, it can become it could help you because it becomes your prompting structure as well. And then you state what do you want the output to be. So I'll jump into ChatGPT. If anyone has any question, please feel free. I feel like the time is very tight, so I'm going very quickly so we can jump right into the whole thing. I'm gonna share my ChatGPT chat.
This is so interesting, though. I've seen those shapes even like on Pinterest, like how it looks, but I've never heard how you can actually make them. That's so cool.
Okay. Um, there's whole there's the whole stigma that you should be like how you prompt should be complex and stuff like that. That's not true. Even if English is not your first language and you're having trouble communicating in English, you can write in your native language. And the better you communicate with it and the more you simplify what you're writing, the better the AI understands you. In this case, I'm using ChatGPT, but Claude is very good at AI scripting. Some people use DeepSeek. I feel like Claude is much smarter than ChatGPT, but maybe in a couple of weeks things change. So you need to be agile in these kind of situations and always try different stuff. So the first thing that I put in is the prompt that I shared before. If anyone wants to, like, maybe I can copy this prompt and put it in the chat if someone wants to follow along. Okay. So it started thinking, and in the first, when it was thinking, it gave me a lot of inputs. This is something that ChatGPT started doing like 2 weeks ago, and I find when it starts giving a lot of input, it tends to give a lot of errors. So I just stopped the chat and I was like, I need minimum number of inputs. I need to start simple and start building it up. So I was like, I need minimum number of inputs to start. So he gave me 4 instead of 7, maybe 8. And then you need to read through what ChatGPT is telling you, but because sometimes it's instructions for you, and this is how you learn. So the more you read while a ChatGPT or Claude or whatever AI tool is thinking, you start understanding more. So here it's giving you the 4 essential inputs, which are R, loops, level, spacing, and then it gives you the Python script, and then it gives you the outputs. So the first thing you do, you copy the code. Do you see my Rhino or no? You don't see him. Okay. I will just share
I
my home
couldn't see
screen.
it just now.
Okay. You
Now
can
it
see it
works.
now. You go to Grasshopper, you type in Python, you wait for it to load, you double click on Python, you delete whatever is written, and you paste the script from ChatGPT. As simple as that. You play, of course you have errors. That's how it is. So if you want to see the error, you can just toggle here or put a panel after output. But basically the first error is that you need to define the inputs and you need to define the outputs. So you go back to ChatGPT, you see the inputs that are listed here, and then you zoom in, you right click, and then you write the R. And it is case sensitive. So if it's a capital letter, it should be a capital letter. If it's a small letter, it should be a small letter. And then if you zoom in a little bit more, you can see a plus sign. You just click on it because you need 4 inputs in this case. Right. Right. Okay, so levels, and the last one is spacing. You double click on it, you play. And then here in the output, you had 3 outputs. You had A, B, and C. Sometimes it names them, sometimes it gives them as letters. So if you want to have it as curves, points, loft, you just need to state it clearly in the prompt. So we're going to go A, B, and C. This time we're lucky. It worked at the first time, but sometimes it just takes 2-3 times to get it working in the first round. But because we wanted to start simple, it didn't create much errors. Like the error I can see is that, no, actually, I think there's a problem with the lofting, but it's fine. And then here, like any Grasshopper, you start adding script, you start adding parameters. So maybe this is 2.5. These are the things that are coming out. So maybe I make them 10. The level is how many we have, so make it 8. Then now you can see the error with the loft. So this is something that we need to prompt in the next step. And the spacing is the distance between them. So maybe we can add a custom preview here so we can see it better. So you need to start. The reason why I put parameters in all of them, because usually there is default parameters. So if you don't put anything, it gives you like a starting geometry. I usually start putting all of the parameters because sometimes there are errors. So because the chat is limited, I try to find out all of the errors and then prompt it at one go. So the first error is that the lofting, I think they're not put by order. So the last one is lofting with the first one again, because if I do loft here with the curves, it's actually working. So there's a problem with lofting. And sometimes with AI, creating surfaces gives a sort of a problem, but we can try to fix it together now. So usually I like to share AI. I feel like, I don't know, it's like a great start. And then I just type, it doesn't have to be perfect English. It doesn't have to be complicated. You just describe what you want. And you don't have to describe by just putting text. So there are multiple methods of communicating with AI tools. You can start sketching, you can take screenshots, because I feel it's better when you take screenshot from the output within Rhino, because it starts to understand what the Python script is generating. So I'm like, I want something that has more of dimension, because I want it to look like a groove in the 3D concrete printed column. And because I wanted more complex, and then I told it that the lofting doesn't work because the last one is lofting again with the first one. And I put screenshot and I put a sketch. So then it gave me a second Python script, and it added 2 new inputs. So I waited until it finished. I copied this and I went back to Grasshopper. Okay. Usually it's better if you have a script that works, it's better to start copying it and then to have something to go back to. So I'll just copy this. I'll disable. I'll double click here, delete everything, paste the new one, play. Now we have an error because we didn't add the 2 new parameters, which are the rotation degree and taper. I think I prompted as well that I needed these two as new inputs because I wanted to have more control over the output. So rotation degree and um, play. I still have an error. So I go here, there's an error in the lofting. So I just click on it, right click. Now it's supposed to be copied. So I go back to the ChatGPT chat and then I just paste the error. It's as simple as that. And then it starts, it is wrong because this is a Rhino 7 with an old Python. So I copied the new, sometimes it just gives you this line. It doesn't give you the whole script. So if you don't understand how to Python script, you can just prompt that you want the whole script. You don't want to, like, instructions on which line to change. So I'm gonna copy this. I'm gonna go back here, double click, paste. And still the lofting doesn't work. These things, they need a lot of patience. But when you start doing it more and more, ChatGPT starts understanding your own workflow and it starts enhancing itself based on your own workflow. So it creates like a better communication way between you and the AI. So if it doesn't work in the first time, this is more than fine. This is very normal. You just need to have so much patience when you're working with it. So I'll put a parameter in the rotation degree. Still the lofting has an error. And for this one, maybe I don't know what is the range of the parameter. So what I can do, I can double click here. I can go into the Python script, and then how it writes the code, it's like dummy proof. So you have here the inputs, and if you go to the taper, you can find that it is 0.2, the default value, and then you have it from 0 to 1. So you can just create a parameter that goes from the 0 to 1. Zero is making it bigger at the top, and then this is making it smaller, which creates error. So I went back to the chat, and then I was like, it still looks like a flower, which is something that I don't want. Not like the second image attached, and the loft is still incorrect. Now I started losing my patience, which is also more than fine. And then, yes, you're right. No, no, no. And it's the same workflow. You just copy, double click, and then and then there's an interesting thing that you can go through the chat after the script, and then it tells you like steps to do. So no, here it doesn't do that, but maybe in the next one. So it didn't create like the groove geometry that I wanted. So I was like, maybe change the whole approach, and I put another image, and I started testing it and testing it and testing it. So it's like a whole chat of back and forth between me as a designer and AI and ChatGPT as an AI tool. Yeah, and that's it. Maybe after we're done with it, we can contour it. And then because every 3D printing company has different considerations, different layer height, different layer width. So maybe this company has 1.5, 1.15 distance. This is the surface. I don't want to crash my laptop, so I'm just... And then I can use mesh pipe. Divided by 2. Now it's going to take time. So I need to make it more refined, but it's okay for now. So I know it's very brief, but it is as simple as that. You just need to start experimenting and putting yourself in communication with the AI tool, whether it's ChatGPT or Claude or whatever you feel comfortable with, and then starting the whole process. The thing is, for example, in this one, the loft wasn't working, but I had curves as an output. So sometimes it's a smart thing not to be too smart with it. If it doesn't know how to create a surface, then that's not a big issue if you know how to do it in Grasshopper. So sometimes you just need to differentiate between, okay, I need this in Python script because it's smarter that way and it's easier that way. But in other stuff, it's easier to just do it with normal Grasshopper scripting. And then the sweet spot is a mix between both. So for the 3D concrete printing part, actually, there was another Python script generated, which was a collaboration between me and the 3D concrete printing company, which is their consideration with their material uh, itself, because each material behaves differently. So it was like, okay, these are our considerations. I started prompting it in ChatGPT, and then I got a new Python code that is like, oh, this is printable and this is not printable. So it's the same workflow. It's just you decide how you're going to use it. That's it. If you have any questions, please feel free to ask.
That was incredible. I was trying to follow along a little bit. I don't know how far I've got. I didn't get the shape yet, but it was super interesting how, because I thought maybe there was still some kind of knowledge involved that I needed to actually script, but to me it seems like I could also do this, and that's a really good thing. That means it's a good, well explained process. So I'm really excited. Those students are lucky that they're going to get you as their tutor next week. I wish I could come as well. That's super interesting. So guys, if you have any questions, I think now is probably the best time because we just watched this whole demonstration. Is anything unclear for anyone? Is there something we should address now? But that was incredible. Thank you so much. I also wanted to ask you. Oh, sorry, I didn't mean to cut you off.
Am I audible?
I can hear you. Yeah. Were you gonna ask a question?
Yeah.
No, no.
Yeah. Hi, Devam this side from India.
Hello.
Hi. I just want to ask, like, if we are giving any script or like writing Python script. So, like, this is just for a column. So we need to do like this much of process for just making a column. So, like, if we are making any model or any space, creating any space. So, like, the same process we need to follow for each and everything, or like, is there anything which could be done all together?
Um, I was trying to do something very simple, but at the end of the day, it is the same process. It is the same logic of having inputs, the process, and the outputs. So in my master's, was doing something more complex, which was data from sound data, and then semantic equation, which is more of mathematical equations, and then the output was a mesh. And then there was a little bit of normal Grasshopper scripting to get the pattern looking more beautiful, and then getting it and optimizing it. So in this tutorial, I was doing something pretty simple, but I wanted to explain how the logic of the process, and then you can start applying it in whatever scale, whatever idea that you have that hasn't been done before. So it's still the same process. If you get an error, you copy the error, you put it in ChatGPT. You think of it as you start simple and then you start building it up. So it's the same logic, and then you start making it more complex and aligning it to your own study, your own design project, or whatever you want to use it for.
Thank you so much.
Yeah. I think there's a question in the chat, which is a very interesting question, which is it better to use AI for creating Grasshopper Python scripts or just doing the normal scripting in Grasshopper? So for this column, I know some people know how to do it in just like 30 seconds in normal Grasshopper scripting. But as you get into more complex ideas, you need to, okay. So you need to start, one second.
No worries.
Some stuff are easier done with normal Grasshopper scripting, and then other stuff are easier done with Python scripting. So the more you use it, the more you start understanding, okay, this is better Python script, this is better just normal Grasshopper scripting, because at the end of the day, you need to be as efficient as possible. So if it's something that is not working in AI and you know how to do it fast in Grasshopper, then it's just dumb if you keep on looping in AI trying to make it work, if it can be done easy without using AI. So so it's a matter of, okay, this is too complex to be done in normal Grasshopper scripting, so I'm going to use AI for it. And this is okay, this is easy, I'm just going to use normal Grasshopper scripting. Because some of the work that's shown out there is just like Python scripting and then normal Grasshopper scripting, and it's just put in a cluster. It doesn't make you smarter if everything is done in AI. It for me, I even use like multiple Python scripts after each other because I feel like it's easier to, instead of having multiple inputs and then multiple outputs, and then it gets a little bit messy for me. But it doesn't have to be done in just the design part. It actually can be done in something in the middle. So for example, there was a project that I was working on. Oh, and also it's because, okay, if you're working on a project and then there's something that you cannot do and you need to find a plugin that makes it work. So I started doing using AI to create my own plugins. So for example, there was a project I was working on, and then I had like shapes that was a little bit tilted and I needed a bounding box around it. So when I used normal bounding box, it doesn't take the rotation into consideration. So there was an option for me to find a YouTube tutorial on how to do it or find a new plugin. And then I was like, okay, why not use Python scripting? And then from the second prompt, I did a small like Python script that gives me a bounding box with the rotation because it's something that I needed within the process. So it doesn't have to be something design for design. It could be just for solving small bits inside the Grasshopper script that makes just life easier. So that's the first question. The second question, did you get the G code for the geometry using? Yes, that's actually something that I've done, which was so interested. I was so happy to do that because when I was doing it before, it was a lot of understanding of data tree and just like if there's a um, like something text at the beginning of the G code that has to be there, you need to put it and stuff like that. And it took like maybe weeks, not weeks, like from a week to 10 days to develop a G code generator for something. And then I was like, okay, why not try to use Python? And then it took me like 3-4 hours to create a G code generator for a certain company. So, and at the end of the day, it's still the same process. And it just takes a little bit of time. And actually, for a funny thing, I had something posted recently, and I wanted to generate like the background that I have. I lost the model, but I had the G code, and I was like, okay, what can I do now? And I took the G code and then I deconstructed it in using a Python script in Grasshopper. So I put the G code as input and it gave me the geometry as an output. So
Whoa.
you can do whatever you want, honestly. It's just a matter of you put your own limitations. Like the tool is there, it's so easy to use. It's about how you're gonna use it. That's what what matters. Yeah. I really
I think there was another question at the end from
oh,
Salma. Oh, and Mariana said thank you for the workshop.
thank
You're very
you.
welcome. We have another question from Salma. Maybe I can read it. So Salma is saying, hi, Rowan, hi, Maria. Thank you for the great session. I really appreciate the clarity of your instructions and love the initiative. I have a basic question. How can I check if a design is actually suitable for 3D concrete printing, especially when it comes to geometry, material constraints, and structural feasibility? Is there any way we can check it with AI? Good question.
That's a great question. Okay, there's two ways to, like for now, there's two ways. The first one is using structure analysis tools like Karamba, or for now there's Karamba, which it checks the structural stability. So you can use tools like Galapagos or Wallisey to just check which parameters make it more suitable for 3D concrete printing. That's like a more advanced way. But the simple way, the way that I was using, is that it was a communication between me and the 3D concrete printing company, because the material constraints the shape that's going to be printing, if it's going to buckle or not. These like kind of information you get either from reading research papers and understanding the process, and then because you understand the process, you start prompting AI to create like a structural checkup that is based on either research or based on the 3D concrete printing company that's going to print it. So it's not like AI is going to tell us, okay, this will make it printable and it won't make it printable. It's more of, I know that if for example, I have this as a layer width and then the other part is shifted a little bit, I know the distance of the shifting before it starts falling. So if it moves for maybe 1 centimeter, it's fine. If it moves more, then it's going to fall. So these kind of instructions, it's either based on research or your own personal research or just reading research papers. And then you can just prompt it in AI and then get your own custom structure checkup thing.
Amazing. Let me check if there's another question. I think. Oh wait, there is. Okay. Amazing workflow. Thank you so much, Rowan and Maria. I had nothing to do with this, guys. I'm just hosting this amazing person. I had a question. Actually, as you're really experienced, so there are companies like Econ, I don't know how to read it, who are creating 3D printing housing in and so on. Wait, what was the question? In and so on. So what is your personal opinion? What specific problem in construction or in which scenario 3D printing construction works better than traditional construction and what it solves? And what is the future of 3D printing construction methods? Oh, that's interesting.
Yeah. Okay, so there is a lot of initiative building using 3D concrete printing because the fact that it's very fast, it needs minimal amount of people, workers, and it's a very heavy material, it's a very strong material. So there's a lot of agenda pushing this kind of construction. But the problem remains is that, okay, do someone want to live in a 3D concrete printed house, or they just want normal buildings? Because sometimes they 3D print house and then they just put material or something to make it straight so you don't see the seams between the 3D printed layers. And the second part is that, yeah, so it's like it defeats the whole purpose. That's the beauty of it. But
Crazy.
and then the second thing is that there hasn't been a 3D concrete printed house that has been there for a really long time for us to assess the livability of it, what are the problems that could be generated and stuff like that. So it's a matter of, it's a very new technology. It's a very interesting technology. You can achieve a lot of more complex stuff that it's harder. It's it's cheaper if you do them with 3D concrete printing rather than normal construction, but still there is a lot of limitation for the technology. So it takes innovators to push forward this agenda to get something that could be built very fast with less budget.
That's so interesting. So, guys, if there's no more questions, I think I want to say thank you again to Rowan. That was incredibly interesting. I really learned a lot. I really love that you just went straight into Rhino and were showing everything. That was absolutely incredible. I'm sure everyone who watches it later on online in the recording will also comment something about how useful that was. I really appreciate that. And guys, if you enjoyed this, I would love to hear your feedback. You can post about it on LinkedIn or Instagram, and I'll be sure to repost everyone who was here and who enjoyed this, because we're really trying to create free education for everyone who wants to learn more about AI and new technology. So thank you so much to our lovely guests. Thank you so much to everyone who was here, and I hope I will see you in the next workshop next week. So that was amazing. Thank you, guys.